Have you ever wondered how your email magically knows what's spam, or how your phone can pick out faces in a crowd of photos? Well, a lot of the time, the answer is a concept called supervised learning. It is, no joke, one of the most important ideas in all of AI, and we're about to break down exactly how it works. So, let's just start with a simple question. How would you actually teach a computer to tell a lizard and a turtle apart? I mean, you might think you'd have to write out a huge list of rules, right? Like, if it has scales, if it has a shell, check the tail, and so on.
But with machine learning, we flip that idea on its head. Instead of giving the computer a bunch of rules, we just give it data. Tons of it. You show it thousands and thousands of examples, and you let it figure out the patterns for itself. But, and this is the important part, it needs a little bit of help.
And that help, well, that's the whole idea behind supervised learning. The best way to think about it is this: you're not just giving a student a textbook to study. You're giving them the textbook and the complete answer key right alongside. So here's the official definition. Supervised learning is when a model learns from data that is already labeled with the correct answer. The key word there, the one that makes this whole thing work, is labeled. And this slide shows you exactly what that means. On the left, you've got unlabeled data. It's just an image. The computer has no idea what it is. It's just a question. But on the right, we have labeled data. It's a pair. You get the image, and you get the correct label, lizard. It's both the question and the answer, all in one package. Okay, so let's stick with our reptile example here and see how this actually works. We're going to use this method to teach a machine to become an expert at telling reptiles apart. So, our training data is just made up of these pairs. The input is the picture, and the label is the correct name. We pass both of these to the model, and its entire job, its only goal during training, is to figure out the connection between that specific picture and that specific name. And this really gets to the heart of it. The model isn't just memorizing pictures. It's trying to build a general rule, a kind of map that can take any new image it sees and connect it to the right output label based on all the examples it studied before. So how does it actually get smarter? Well, it's not a one-and-done thing. Learning is a cycle. It's a loop of guessing, checking its work, and correcting itself, over and over and over again. This is the learning loop, and it can happen millions of times. So first, we feed it an image. Let's say it's a lizard. Second, the model makes a guess. Maybe it says turtle. Third, we compare its guess to the correct label we already have. It was wrong. That difference, that amount of wrongness, we call that the loss. And finally, the model uses that loss to tweak its own internal wiring just a little bit so it's less likely to make that same mistake next time. And that right there is the engine of learning. Through thousands and thousands of examples, the one single objective is to get that error, that loss, as close to zero as it possibly can. It's just a constant process of self-correction. Now, here's a quick but super important detail. Computers don't really understand words like lizard or turtle. They speak the language of numbers. So before we start, we have to encode our labels. Lizard might become 0, turtle becomes 1, and so on. This is what lets the model do the math it needs to do to figure out the loss. Okay, but this doesn't just work for pictures. Let's look at a totally different example. Let's say we want to train a model to predict something based on a set of measurements, like a person's height and weight. Our data would look a lot like this table. Each sample is a set of numbers, weight and height. And for every single sample, there's a corresponding label. In this case, we've used 1 for female and 0 for male. We're giving the model both the inputs and the right answers. And this is absolutely critical. The first label in our list has to match the first sample in our list. The second has to match the second, and so on. They are inseparable pairs. The computer needs to know exactly which answer goes with which question. There can't be any confusion. And if you were to actually peek at the code for this, you'd see a line that looks something like this. This one command, model.fit, is where all the magic happens. We're telling the model to fit itself to our data. We give it the x values, those are our samples, the questions, and we give it the y values, those are our labels, the answers. We are literally just handing it the questions and the answer key. And at a high level, that's really the essence of it. Yeah, the math going on under the hood can be pretty wild, but the basic idea of providing these question and answer pairs is surprisingly simple. So you're probably wondering, can a model learn without an answer key? And the answer is yes. That's a whole other category called unsupervised learning. There's even a middle ground called semi-supervised learning. But for now, what's important to know is that supervised learning is the absolute workhorse of AI.
It's the foundation for so many of the apps you use every single day.
Okay, so as we wrap up here, let's just boil this all down to the most important points, the stuff you really need to remember.
So if you remember anything, remember this. Supervised learning needs labeled data. That is the answer key. The model's whole goal is just to learn how to map inputs to the correct outputs. And the way it learns is by guessing, checking its work, and trying to minimize its errors again and again.
And that brings us to one final really crucial question. A model is only ever as good as the answer key we give it. So if an AI is learning directly from the labels we provide, what happens when our labels are biased? What happens when they're just plain wrong? It's a huge challenge in the field because the quality of our data directly controls the quality of the AI. It's a powerful reminder that even the smartest systems are still built on the foundations that we give them. Thanks for listening.